we have to be careful. I think that pose is probably not for recording. That pose is probably for screen sharing. So don't put the first part in the cloud because that can get me into trouble. Okay.
For the next part?
Yeah, for the next part, yes, please.
Yesterday, all of us have seen there were some failure, some crashes on my calculation, and it was, I'll keep saying sort, like it
Yes,
was
yes.
because of the atom number that we put on, as I have put 1 and 40 for the atom position, and those were taken from the PDB format, and we have calculated those on BMD. The PDB format is the one that made those wrong, and earlier we calculated like first of all that PDB file was generated from XYZ using OpenBabel. Later on we again regenerate that from the bash, or we can regenerate that from AMPS also. So
And
that Packmol one.
yeah, we'll come back to this part once we see the script, because later we'll do the script together on Crunch. But I think, Teresa, to show them this issue, maybe it's worth going to the
Yes, 0, 0.
Because it starts from 0, that's...
No.
So Teresa will show you. So if you go
I
to the
think
0,
I have to git both.
No, don't git both, because this one is the old one, and
Yeah.
you'll see the problem in the output folder. So output folder is the generated structures. We have four of them.
These one.
And the problematic one turns out to be the Packmol, the pack system.pdb.
That PDB one.
So if you...
Oh, okay, I remember what to so. Oh, it's this. See, the position of the carbon and hydrogen is not aligned here. And we have, what should I say?
So let me explain a little bit, because this one I didn't explain this morning. So what happens with Packmol is you have the impurity, or so in our case we have 1 impurity and 31. I'm not sure how many do you have. You have, but in S-Link case we have 31. So the input that we wrote is essentially throwing the impurity first, and then throw the given number of solvent around it. And we want to have it in the periodic boundary condition. So what Packmol does, this PDB file is the output of Packmol. And when we throw it in, what happens is that we have the first molecule starting in the beginning, second molecules come after. So the radical turns out to be the first one, which makes sense. I think it was actually coming from the CCC PDB. But when we do format conversion with OpenBabel, when we convert, for instance, to VESP, that is the one that we use for Barata and Deepa's case to identify the radical position. They actually reshuffle it in such a way that they have the atom types all together, the same atom type all together. And it happens just to be that the hydrogen was the one that is in the beginning. So they are not fully aligned. So the numbers that we actually saw from the PDB file using VMD in Teresa's case yesterday, because she doesn't have VESP on her computer, turns out to be not the right order. So we actually pick up the wrong atoms. Pick up 2 hydrogens.
Yeah, 2 hydrogen, yeah.
Yeah, so Teresa, can you show the VESP file so that we can convince the team?
Is that affect for other calculations also?
Yeah.
No. Oh. For Teresa's other calculations, but not for yours, because you were using the VESP files, and the crystal coordinates that we extract was actually converted from was from AMPS, but it was actually from the same order. So that's why in Barata's case, we have previously did multiple different checks. We take the trajectory from the active learning and we look at the numbers if they are consistent. So it was just the Packmol that was giving us the trouble. So Teresa, can you tell us a little bit how we solved the problem?
I don't have that file.
That's right. You don't have that here. Okay, so I think this is a good version. Maybe we can switch to mine. And I think that transitions well into directly into the Packmol part. Do I have the assignment activity? Okay. So what turns out to be is this is a complicated script that we have seen before, but the key is essentially here, as the comment sort of suggests that we are trying to solve this problem, and basically what we wanted to do is we have used OpenBabel to convert the PDB files into VASP, and VASP as input to convert into ENS format, and later ENS format to convert into fractional coordinate. This is not via OpenBabel, but this will preserve the same order of the atoms. So the only thing that is inconsistent is the PDB file. So what do we do? Well, you can do many things, but this is one thing that surfaced in our mind. So basically, we said we don't like it. Let's kill it, and let's just take whatever VASP file and then we'll convert it back to PDB. So in the end, it turns out to give us the same order. So that's what we did. And I think we have, well, I'm not sure because I haven't go extensively tested for each one of them, but we have it applied for all the examples that is there. So this is the crunch one. Let me see. Yes, we do have it. Okay, so for now, I remember Priya was just asking the question yesterday that how to do this on crunch, and even though in one of our previous meetings I was going through using this apptainer example to explain the container technology, we didn't have time for practical session, so why not let's do it right now, and we'll get once you have done this once, you'll know how to do it. Okay, so let me see. Before we start, let me plan it. Perhaps the best way to do it is I show you how to do it once, and then you guys do different systems. For instance, Deepa will do the PVC, and then Teresa will do polypropyl. Well, Teresa, you did enough today, so I'll take your role here, and but practice later. And so Bartha, you do your favorite system. And Priya, you can do the isobutylene. I think it's probably ready for processing, right?
Yeah.
Okay.
I already run.
Okay, very good. So you have the input, but just don't know how to run that crunch. And Priya, don't worry. This will not charge. So as long as you as long as you are not doing S batch, you are not being charged. A word of caution is don't run huge stuff on the logging node. Somebody will go behind you and go after you and say, "Oh, you are doing things very bad." This is a small enough problem that people can run a logging node. Okay, so let me show you how to do it. So let's go to crunch. Let's see. So the typical way that I would suggest you do is I probably should put the documentation to the, well, let me do it right now. Let me put the documentation to the group applications so that you have access to. And for Priya's case, because I'm not sure if Dr. Patrico has added you with the correct group, so I'm going to change my setting here so that you won't get into issues of permission issues. Let me add artist plus read. I think this would make
I'll be clear for you. Because I cannot see.
Oh, that's right. That's a good idea. Well, so we'll do this. Let's do it step by step. So before we start hands-on part, the first milestone would be we copy the example to your local say copy to your home. So let me show you how to do it. And before we go into that, let me first skip poll because this one is not up to date. You don't need to do that because you cannot do it on the group app because that's my folder. But once I pull, you'll be able to copy the most recent one. So the first step we have to do is to copy an example. So what do we copy? We copy the group app, and I'll put the path in the slide. Let me see, because I think not all of us are on the Zoom meeting, but or maybe you can look into Zoom. I can put this on the chat. Yeah, that's also another thing I like having help with meeting modulation because I'll be doing things. Okay, so what I'm going to give you is the path. Okay, I think all of us are here, so let me put this in the chat. Oh, I should be a bit more careful here because not all of you are in the home. So basically this line copies this template to your home or to your current position. And the template is the one inside, or there's a number of folders, but basically that's the example for polypropylene. And we have popular radical and that crunch fork. So that is an example for crunch fork.
We need to copy that on KRG doc.
From KRG doc. So if you look at the path here goes from your home to group app. This assumes that you have a group app linked in your home. Well, I'm not sure if this is true for everyone.
Yeah. We have no group app.
I don't know. I cannot see
Okay,
any.
so let me actually do it a bit more forgivingly. Use real paths will give us real paths. Okay, let me give you this true path. Let me post. And, oh, I cannot post. That's okay. That's okay. Okay, so we're all on the same page, and let's go into this folder. So now in your current path or current folder, there is an example polypropylene and propyl radical crunch 4. Let's go inside. Yeah. So once you are inside, this is essentially the same content as you probably have seen and try to use for your specific systems. The only thing that is different is in the ROM file. So you probably don't need to do it right now. Let me just show you. So basically the ROM file is different by using apptainer, and they are essentially apptainer version of all the Docker commands, and then uses appropriate Docker containers. So whenever you reach a particular line, so this would the procedure that this code will run is we'll first run this. So it will go sequentially, but the actual activation. So these are definitions of functions. They don't activate until you code them. So this is the first thing that went into action, and now we call those functions here. So it still follows the same order. So the first thing it will do is it will try to do a for loop that goes through monomer XYZ and convert it into a PDB file. This is for the need of Packmol. And when we reach this position, your apptainer will try to download from Docker Hub our custom Open Babel. Well, this is not really custom, but it's yeah. Why do I have a separate one? I think I might have added some custom things in there. I couldn't quite remember. But it downloads from Docker Hub, and then make an image that is for apptainer. So you'll see the first time you run it will do some download, and then later it will download the active program in a container, and then finally it will download Packmol. So we won't go into this again in details, but basically the difference is we switch the container technology to Open Babel. Sorry, apptainer, I'm sleepy. Okay, so the only thing that you have to do for this particular example is to run it, and yeah, let's do it, and then we'll. So wait until everyone starts running. It will take some time for you to get the containers. Okay, let me know if once you are ready and then the code is running. It's all running, right?
Yeah.
Okay, good. So while the code is running, it will take some time to download. The only thing that you have to do for changing it to your specific system is as you typically do when you were doing the Docker version. So you want to change your impurity XYZ, and you want to change your monomer XYZ based on your system. And you may want to change compute system based on, so if you have a bigger system or well, obviously your molecular weight will be dependent on what the monomers you're looking at, and a given density that may be a good liquid density, for instance. And the number of molecules depend on how big your solvent is. The bigger molecule you have, you cannot make as many molecules as you would for a small molecule, and expect to have a similar system size. The system size is typically for our purpose, we're doing ab initio molecular dynamics. The system size we can typically comfortably afford is of the order of 1 to 1.5 nanometer in each side, and we're looking at fluid, so we have a cubic cell. The number of atoms is of the order of a few hundreds. So that's the guiding principle that when it comes to setting up this particular calculation, which I think Bharata probably have already went through with all of you.
I said about the size 1.13 to 1.14 lattice.
I see. Okay. Yeah. So I think pushing towards 1 nanometer is a little bit too small. But if you're sort of like hungry with computational resource, you can probably push it a little bit. This is generally empirical, and the one really need to do some K-point related Well, for fluid, you cannot do k-points. So you really have to do a system scaling to see how things work. And you can converge the finite size effect. But that's I can tell you that's quite a bit of work to do. So we are starting from something that's from empirical principles. So typically, a bit bigger than 1 nanometer is a good size for insulators. So those are some guiding principles. All right. So now have all the example population finished? Okay, they're still downloading things.
My one is finished, but I have opened the warning image and it cannot initiate database.
Oh, that's normal. So we have seen this in one of the previous discussion, and for space group related database, you don't need it in this case because we are dealing with disorder system. So it's like no symmetry in. Oh, it's not like it's no symmetry in in our case. So no need to have a database for the space group. I see DPass calculation finished. Barotas calculation finished. How about
Still running.
still run? Okay. Maybe Priya can share.
Yeah,
No,
yeah,
it's because we download everything.
Oh, I see. So
Oh,
probably because Barata and Deepa has previously downloaded part of it. Yeah, the issue of container is because it downloads the container every time. Well, downloads container whenever necessary. So when you do it first time, you don't have a cache. So basically, you have to download everything. Once you download once, even though there are some updates, the container technology basically adds the difference like Git does. So it's much faster once you have run it once. And so I think that's basically what needs to be done for using this this example on Crunch 4. So pretty much you can expect this is exactly like what Barata has gone through in the tutorial, but you copy a different template.
So more easier because we can do it on Crunch.
That's right. You don't need to worry about when you have an
local GI.
Yeah, container technology is supposed to be pandas, but as time goes, people want things more aggressive. So the first thing that came in was I think, well, this is not I'm not very good at history, but I think the first hiccup that comes in is GPU, because GPU it has some hardware level drivers. So if the driver is not the same, it's kind of similar to not having the same CPU architecture. So you have to do some weird things. In this case, apptainer has, well, I don't have it here, but in some other examples that I have, you can see that there's -NV. So this basically is a plugin in apptainer that probes the NVIDIA driver and try to connect it well. In other cases, you need to deal with I don't know if they deal with AMD. I think so, but I don't know what is the right flag. This one got me scratching my head for months when we first started configuring the new cluster. Not saying that this adding this flag, but it was because the drivers was actually incompatible. So I was working with Dr. Katriko to install the new driver, and that took us a month to figure out.
I have a question.
Yes, of course.
Not related to this about OpenWebel. Can not OpenWebel change that WAV format to other format?
A very good question. So Teresa, this question reminds me of I don't know if Campbell made a comment in the meeting when he visited, or when he was at my home. He was basically saying that parser is very difficult to deal with. So the comment, well, I'm diverging. Pull me back if I cannot finish in 2 minutes. So the context of the comment is he's trying to advocate for a language called Julia, which is a high performance language. And his point is always stay in the Julia code where you can, because whenever you have two different languages trying to communicate, you need the general or the typical approach is write the output file and then use the input file for the other one. This is the input file reading from output. The output file reading for a different program is called parsing, and the parsing is actually a difficult problem and easy to make mistakes. So he's making the comment that why not parse? Just use the same language. So that was what his comment was about. And how is it related to Teresa's question? I'm glad I finished the context in 1 minute. So the context here is the WebP is a image format. So image format and so image format is a different class as opposed to chemistry or material science format. So OpenBabel's scope is essentially format conversion within the chemistry material science formats, which is already a mess. And writing parser is hard enough, not mentioning potentially incompatible formats. So that was where the divergence comes from. So
PDB, SDF, something format.
So the interesting thing, and a general comment is when looking at format converter, they typically have something called supported formats. So you can see how many formats they support. every item here is the format that they support. It's kind of remarkable. So whenever you can use existing packages, because reduce the probability of making mistakes. And when using other people's code, always test something. And this could be easily just open it up and then visualize. One thing that we didn't test, and it's not obvious, was the order of the atoms. Which you see that the code Teresa and I, which is okay. This is not a rookie's mistake, because it is a pretty nuanced mistake, and as long as we can correct it, in the end the result is good. All right. Did I answer the question? Yes. Okay. Good. And did Priya's calculation finish?
Yes.
Yeah. Okay, cool. So then we are now in hands-on session. Please modify the proprietary example to your assigned example. And Bharata, can you post recording here? Yeah. So interrupt you for 1 second, and this is one thing that so Deepa was asking a question that whether this should be done on the home folder. The short answer is yes, and the longer answer is the current format, the current example that I'm giving you does not take into account of so it will fail if you put into the square file system. I think Bharat has seen this issue before. It is because on Crunch computer, the default configuration for containers does not include a mounting of a file system that is on the Scratch file system. So what that means is when you are inside the app container, you won't be able to see the file system that associate with the Scratch file system, and that will lead to this inability to find the input file. So if you see that, you have two options, or at least two options. One option is do it. In this case, this is a pretty light calculation. Bring it to your home and run it at your home, and then the problem solved. For heavier,
And after calculation, we can move.
you can move, yes, because it's only the apptainer that cannot see. but other things you can see. For Bharata's case, so he previously seen this issue in a different context, which is this is the more sophisticated script that we're running with active learning. There are two comments that was not discussed in the simpler example that we just covered. One of them is this minus MV, which we briefly mentioned. That's for GPU support. Because knowing the GPU architecture from the system, whole system is necessary. And the second part is this minus capital B. This is called file system binding. And it has to be bound in a way that's a little bit, it's a little bit more involved to think about it, but I figure it's necessary to talk about them. So you cannot bind anything. You cannot bind local paths. At least I think that wouldn't work. Haven't really tried. Maybe they have fixed it. But what are we doing here? This is actually a file system that corresponds to something called a mount point. Let me type it so that you know exactly what I mean. It's called mount point. What is a mount point? Just to see a mount point, let me go to Crunch and then show you what that is. You can see ls block. Let me see. Is this a good example? Not the best example because it's a network file system. Let's do DF. And unfortunately, DF includes a lot of things. So there's the remote file system and the temporary file system. But what I wanted to show you is the scratch. So only look at the scratch. So the less column here correspond to the mount point. It is where a particular device, or you can think of it as a sort of like hard drive, or a virtual hard drive that is a cluster of many drives. They are a device, and let me show you something a bit more conventional. So this is my local computer, and this is a device. This is a partition of my solid-state drive that is connected via the NVMe technology. So you can see this is the zeros NVMe, and there are some subpartitions. It is mounted to the slash, which is the highest level file system, but you can have multiple sub-file system being mounted. For instance, my home is mounted in a different partition of the hard drive. So it's easier to think about what mount point is coming from a drive perspective. But you can also do it with internet storage file system, which is in this case this slash storage on a different machine, which is in a pretty sophisticated namespace. But the long story short, this device is mounted to this mount point. And when you bind the file system, you want to bind with the mount point. To further explain that, I don't know if I have the right language. And
so we are doing Colab. I think we need to mount to drive.
Okay, nice. So it's because when you do container technologies, you also so for different container technologies, you also have to deal with mounting.
We need to run calculation on drive. We need to mount.
That's right.
Our drive to.
Okay, so I'm glad that you have seen some of these before. So for different container technologies, Docker, Shifter, apptainer, Packmol, I think that you all have to deal with mounting. I haven't used Packmol, so I'm not sure that is the right statement. But the Shifter I did, and the apptainer you are seeing now. Docker you see not necessarily mount point. Okay. Any questions so far? I know this is a little bit off the tangent, not really chemical science.
Computer science.
Computer science, computational science, or computers, basic computers. All right. So now let's continue with the hands-on part. And Bartek, you can post the recording. Okay. So what is the question?
Most group by
Oh, so you have the isobutene and the radical. That's the maybe that was from what Paradise prepared. So basically, this turns out to be the same question that Deepa was asking. So I'm glad that you're thinking about the same question. So basically, let's recall what well, I didn't went into details today. I went into details last time, but this script basically have let me annotate. This script basically takes the XYZ files, and oh, we don't have any XYZ.
We removed that one.
I see. So I would think probably you still have a copy in the folder. Okay. So basically the XYZ files, the monomer XYZ, impurity XYZ, are the input files, and the compute system size and this script contains the instruction as to how many and what is the system size you want to put in. So basically the three files are the essential files that we expect a user to provide. The PDB files, impurity PDB and the monomer PDB, are generated by Open Babel, so they are going to be override. So even if you don't remove them, it's okay. The output folder is the folder that contains the generated results. Output ref is something that we put as a reference, but since we copy from a different system, so it's no longer correct reference, so we should delete it just to not confuse ourselves. And so that's basically what I would suggest you do. So remove output ref and then copy the XYZ files here and also the .m files.
Those you shared or those he made?
So those I have shared with you example, but the content has to be modified. So the monomer XYZ contains a single monomer, which is the solvent, and the impurity is the radical in this case, and the compute system size and latest dimension. You have to provide the density of the system, of the liquid system, liquid monomer, and the molecular weight, as well as how many molecules you want to put in the unit cell.
History.
I will post it. Please record.
And go to local.
Just type
Why
this
this
tab.
up? Oh,
Space. That system was.
So what I'm going to ask Tifa do right
That's
now
why
is to show you how to copy
you
back.
don't
You
have.
need to copy back.
Mhm.
Yeah, so what I'm going to ask Tifa do is how do you copy back the results and then check if you are doing this if things are making sense? And I'm glad Bharata is asking this question. This is the right thing to ask.
Okay,
We have
So where are we, Tifa?
divided.
we are in the crons. I'm inside the file, like my file example vinyl and vinyl radical crons. And once I run the run.sh, I got these files. I think everyone got that. And then we need to go to output. And then we can get different files, msprac, pdb, and paps file. Then in Vesta, we are looking for paps file. Then we can check the real path of that file here. And then we need to
Real
copy that.
This one. This
Can
one
you
back
see?
here. Just you can do P and tap that and B. Tap.
And
And
then
quick question for Bharata. Do you know if we have Vesta crunch?
We have crunch. Yeah.
Okay, so for those of you who does not have Vesta, in the words,
we have Western crons. I think we do not have.
I think we have.
I don't have.
We do not have in the
Okay.
crons.
We don't.
Okay, go to your local
Yeah,
computer.
that's okay.
Yeah, and then go back to your local computer.
No, go down. You cross in your own. Like next, open next. This.
Control N, Command
Control
N, Command N.
Okay, go there. And do SCP.
Yeah, SCP and your UID. And command is
Just to
added
say
it. Yeah,
UID also. You can just do by cron score also.
Yeah, I think I'm not sure about Priya's case because I'm not sure if Priya has set up the
Just
SSH config. But if you have set up the SSH config in our previous
just try
meetings,
doing just cron score. For in your case.
Yeah.
Cron score.
.kim.event.
No,
just control.
just cron score. Now just semicolon. G, there is G, I think. G or what?
You need to remove that C.
Oh,
Just no, you cannot do. I think you have to type everything. Just what is your UID?
And then space start.
Everything like crons dot.
yeah.
After that, we can then do that, but I don't know. You have to type up, yeah, unity.edu, then semicolon, and that part, the previous one from here. Go to here. And copy this part. Everything, like, from starting. Copy. And go here. And paste here. And give a dot also for the list. Is this and dot. What is your first? Yeah, it's there. See?
Okay, so
Now,
Tifa,
we
please
have
continue
Vista.
and
Okay, then if you have
Open
Vista,
Vista, like
then
that.
type Vista,
Vista,
this
VESTA,
file, and
VESTA,
then you can visualize it.
VESTA. This and this file. P. And enter. Okay, you can see now. It's nice.
yeah, so you can, yeah, generally speaking, this is not a
No.
bulletproof test, but typically our eyes will tell us, especially for chemists, if you rotate around and you'll see
Yeah,
monomers
inside,
and the
yeah,
radical.
Yeah, this one is the radicals. You can see here, this is my radicals, vinyl radicals.
Just go.
And this one is monomers, this one also.
Right, so if we don't see anything crazy, then that's probably a good sign, and generally speaking, I would always say, when you start a big calculation, take a few minutes to take a look at the system. If you see things that's like atom soup, that the atoms are crunched together, then it is probably something probably wrong, and it's not worth the time to run the calculations on those. Yeah, thanks, Partha. Good question, and thanks, Deepa, for presenting.
Can you stop?
Yeah, please.